So we are starting a brand new chapter today. Chapter 4 is all about this idea of congruent triangles. Now, we've talked about congruent before. We've just talked about congruent angles, congruent segments. Now we're going to eventually apply it to proving congruent triangles.
Okay.
Like most of the chapters we've done so far, it's kind of eased into that idea of proving stuff. So we're going to start with some basic, getting some vocabulary out of the way. You're going to notice this particular section has lots of vocabulary. Okay. The good thing, though, if you've noticed this as well, Ms. Hooker, a lot of these words we've seen before. So
a lot of them we've seen before, and you're going to just keep seeing them over and over and over again. So this is stuff that you do need to know.
Yes. So first of all, since we're talking about proving, or going to be eventually talking about congruent triangles, we need to know what a triangle is. And we're going to eventually also talk about some things about some angles involving it. So by the book definition, it says a triangle is a figure formed by three segments joining three non-collinear points. All right, so if I have three non-collinear points,
So they don't all make a straight line.
okay, and I connect it, making a segment between each two pairs. All right, so here's a segment, so on and so forth. Notice what's formed is a
triangle.
All right, and so these, a lot of times when you say three segments, a lot of times you'll say three sides. So when you say triangle, of course, we're thinking a figure with three sides. All right, so we're going to establish some things that we already know about triangles, but we're going to elaborate on some things that will be new as well.
All right, so there are three basic triangles that we know of. And you guys have seen these words before. They're not new words. But we'll classify our triangles. We can classify them by the sides that they have or by the angles. So we're going to start with just the sides. There's three terms that we've used. Equilateral, meaning when you hear that word equa, kind of means they're equal. So equal sides, congruent sides is going to be our formal definition of that. Equilateral triangles will have three congruent sides. An isosceles triangle, I know you guys have seen that before, is when we'll have two congruent sides. So if I drew a picture equilateral, we know all three sides are congruent. An isosceles will have two sides that are congruent, but a third one that is not. And a scalene, and really isosceles technically could have three congruent sides. It has that word at least.
Yeah, I was going to point that out.
Yeah, but when you know that it does have three, the reason I say at least, because this third one could be congruent to it, we just don't know that.
Yeah.
So when you know the third one that's congruent, we do say equilateral. We go to that more specific definition.
And add to something to that is the reason why they throw in that at least two congruent sides, because there's characteristics of isosceles triangles that equilateral triangles will have as well. So they throw that in there so that way you can kind of use the same properties of things.
Absolutely. And the last thing that we have is a scalene triangle, which is when you have no congruent sides. Usually you'll notice that those side lengths are all going to be different.
Yeah. Or they will have it labeled where one, they won't have it, like they'll have like different tick marks in a sense.
So you could have 1 and then a 2 and then a 3. Typically, when you're looking at a picture, you're going to be able to kind of get an idea of what it might be, but we can never assume. Never
I love
assume.
that she was going to say that. You were reading my mind almost. I was about to say, we can't really assume any of these things until, we can't assume ever, but we will know what they are based on what they're providing you. Eventually, later in this chapter, we're going to learn some cool things about each of them based on what you know about their angles. But right now, we are just, by definition, we know it's all about, are their sides congruent or not type thing. Now, the other type of classification, now this is classifying triangles. We can classify by angles as well, right? Notice there are 4 ways we can do that. The first one is an acute triangle, which basically means that all 3 angles have to be acute.
They're adorable. Acute angles are just adorable.
I was waiting for her to say that. Obtuse triangle. Notice it doesn't say 3 obtuse angles. It says just 1 obtuse angle. And that's because of something you already know, and we're going to actually talk about it later on as well. But why couldn't you have 3 obtuse angles?
Well, I know that an obtuse angle has to be something more than 90, but I remember back from middle school that all the angles in a triangle together made 180 degrees.
Yes.
So if one by itself is more than 90, I couldn't have 2 that were more than 90.
Or even 3.
Yeah, definitely more than that because it'd be more than 180 degrees.
So acute triangle has to have all 3 angles acute. Obtuse, 1 obtuse angle. A right triangle, which you guys have learned about and done a lot with. Again, that 1 right angle idea. So a lot of times you see it, kind of a visual sketch. So you can kind of tell that that's going to be an acute triangle. Again, we can't make assumptions, but you know, we can later on we'll be able to do some more with it. Obtuse triangle, kind of draw one that has an obtuse angle, a right angle, a right triangle, I mean, one right angle type thing.
Yes.
And then the last one is an equal angular triangle, which is kind of a hard word to say. Equal angular, so like equilateral has that equal part, which means something's going to be equal. And notice they're talking about the angles, so there's going to be 3 congruent angles. So if you have a triangle with 3 congruent angles, you're going to see that kind of with the marks here. You want to take a kind of maybe a educated guess here, Ms. Hochgrabe, what you think those angle measures are going to be?
Well, if they're all the same, and I know that all together they're 180 degrees, then 180 divided by 3, they'd be 60 degrees each.
So that's also another way to kind of know if it's equal angular.
Now, an equiangular triangle, I'm looking at that. If they're all 60, is it also an acute triangle?
You were reading my mind as well. Okay, this is also, so equiangular also means acute. Now, does acute mean equiangular?
No, because you could have those angles being different and that would be okay. So we always want to go to the most specific description of those triangles.
So equiangular would be a great description for a triangle if all the angles are the same measure.
So would I need to call it an acute equiangular, or I would just say equiangular because I know?
And like you said, the most specific.
Most specific.
Okay.
All right. Within our triangle, we've got some things that we need to talk about. We need to be aware of this vocabulary. First of all, the vertex of a triangle. It says each of the 3 points joining the sides of a triangle. And technically, there's not just one vertex to a triangle. There are 3 vertices, and that's our plural term for that, vertices. So looking at this picture, we want to talk about the points that are joining the sides of a triangle. Those would be considered our vertices. So what points do you see here that are joining those sides? What are the vertices of this triangle?
In that particular triangle, that would be point A, point C, and point B.
Perfect. And we know it's just the points. It's not going to be the side itself. It's the vertices or the points. You'll see that, usually that's where the angle happens at where that vertice is located. The adjacent sides, when we're talking about adjacent, you've seen this vocabulary word before. Adjacent is when you have 2 sides that share a common vertex. We've talked about adjacent angles. We've talked about things that are right next to each other. That's kind of the same idea when you're talking about sides of a triangle. They're adjacent if they're right next to each other, if they share a common side. So what would be an example in this triangle?
Well, in this triangle,
if I look at
side AC would be adjacent to side CB and side AC. Or AB, sorry.
Okay, so AC would be adjacent to CB if I look at point C. But you're also saying that segment AC would also be adjacent to
AB.
AB.
Segment AB.
If I look at point A being that point that they have in
So
common.
really, in a triangle, any side that you have is adjacent to the other side.
Exactly.
But what I'm thinking, that word adjacent sides, we're kind of throwing it out now, but when we get to other types of figures like quadrilaterals or things that have more sides, 5, 6, 7 sides, not every side is adjacent. But in a triangle, it's kind of unique in this case.
Right, exactly. Now, to name a triangle, let's think about how we've named things in the past. We name points with just one vertice, right? With that one point, one letter.
The capital letter.
Exactly. We named sides or segments with the little segment bar above it. We named it with the 2 endpoints.
So points again.
Points again. So we're getting this idea of we name things by points. But if I just had 2 points, that would only be a what?
A segment.
Or a side. Or a line or whatever. So how do you think we're going to name a triangle?
Would I name the triangle by all 3 of its vertices?
You got it.
So, and maybe use a symbol for it. Could I use the triangle, like an actual triangle?
Sure.
Draw a triangle. So name this triangle. What about ACB?
ACB. Sounds great. Now, is that the only way we could have named this?
No, because it doesn't matter the order. So triangle, maybe BAC.
Yeah. There's lots of ways you can name these. And I love that you said we knew we needed a little symbol. Because if I just name 3 points, I'm talking about a plane. So I need to know that this isn't just a plane, but it's a very specific figure. So when we're talking about triangles, we're going to be using just a little triangle in front of those 3 letters to name those triangles.
Which this is a plane, but I like how Ms. Hochgrabe said, more specific.
Yes.
We want to make sure we're clear that this is a triangle.
Exactly.
All right, some more vocabulary. Notice the two types of triangles we've already defined. A right triangle has one right angle, and isosceles triangle has at least two congruent sides. Now, when we're talking about each of these, there are some other vocabulary terms that we need to be aware of. Hypotenuse, which we have seen before. Okay, it says it's the side that's opposite the right angle. So it's the side that's opposite the right angle. So here's the right angle, angle B. So what's the side opposite of that?
AC would be opposite.
So this would be your hypotenuse. So I put segment AC if I was naming this. Now, they said the legs are the sides, notice that's plural, that form the right angle. So what sides are forming the right angle?
Segment AB and segment BC together are what come together
Yes.
at that vertex
They
B
make
where
this.
that right
So
angle
this is a leg and this is a leg. So those segments make that right angle happen. So in a right triangle, you have sides that are legs and hypotenuse.
Now, I remember seeing these words before because I remember in middle school we learned about the Pythagorean theorem and we talked about the hypotenuse and the legs then too. So hopefully this isn't new vocabulary to you guys. It's just a refresher.
And what's kind of cool is we spent a whole chapter on right triangles in second semester. So you'll learn a lot more stuff that using stuff you already know and just adding to it. So
Guys, we have several chapters that are on triangles this year. You're going to learn more about triangles than you probably ever cared to know before.
yes,
And you're going to be amazed at all the
they're
relationships.
pretty
that exist.
fascinating polygon out there. So,
really are.
all right. So isosceles triangle. Notice it starts with the same kind of vocab, the legs. All right. So does that mean in an isosceles triangle that the legs are going to form a right angle? No. Notice this definition. Like a lot of definitions in our English dictionary have multiple meanings. The legs in an isosceles triangle mean two congruent sides. So in this picture, what are the two sides that are congruent?
Side RS and side RT.
So this go around, a leg are the sides that are congruent, not necessarily forming a right angle. Now, could they form a right angle?
Well, sure. It could, because I know I've heard of things like isosceles right triangle.
Yeah.
So if that happens,
So if they form a right triangle, then it's an isosceles and a right triangle, but it doesn't necessarily mean that's the case always.
Okay.
All right. Now, the other term on this slide, it says a base. Now, it says third side. That's how the book defines it. I often like to say it as I'm going to elaborate, the non-congruent side.
so that would be side ST in this figure.
So it's basically the side that is remaining. Now, often, and I don't know if you see this too, Ms. Hochgraby, but I often will see students that think the base has to be at the bottom.
Yeah.
All right. Notice we purposely drew the triangle where that wasn't the case. The base doesn't mean the bottom. It means the side that is the not congruent to the other two. Okay. And if it was congruent to the other two, then it would be considered an equilateral triangle, which has different characteristics as well. So there wouldn't be necessarily legs. Okay.
All right. Okay, we have lots of vocabulary.
Yes.
You weren't kidding, Mrs. Palermo. All right. Interior angles. Those are going to be angles that are inside the triangle. That makes sense. Usually most of us understand the idea of interior angles. There, of course, will be 3 interior angles in every triangle. Now, exterior angles. This is the one that's a little bit different. They are outside the triangle, but there's a characteristic here. They are adjacent to the interior angles. So if angle 2 was an interior angle, the angle that's adjacent to that would be my angle 5 that I have marked here. A lot of people want to think it's the vertical angle to that. It's not this stuff up here. It is definitely the angle that is adjacent to it. What do you notice about those two angles? What do they form together?
They're a linear pair.
They're a linear pair, and that is important. That's something that we need to be comfortable with. When you see exterior angles, think linear pair
with the interior
with
angle.
interior angles.
Which basically means if they're a linear pair, then an interior angle and exterior angle will be supplementary.
You got it.
So if I knew the exterior angle, I could find the interior angle.
Or if I knew the interior angle, I could find the exterior.
Cool, okay.
You got it. Now, each vertex has a pair of congruent exterior angles, right?
Yeah, because I was thinking when you were kind of pointing out those angles, when you think exterior, first thing you do think is outside, and I see 3 angles that are technically outside. And Ms. Hochgraby mentioned that the one vertical to the interior is never what you're going to use because it has to be adjacent to it.
Right.
So the two that she circled there, those two are both considered exterior. However, I'm noticing that those are vertical angles to each other, which means they're the same measure, right?
Yes. So when you're talking about an exterior angle and other keys, we only show one.
Okay.
We only worry about having
So
one.
how do I know which one I use?
It really won't matter because, again, we're talking about both of them being congruent angles. So
Okay.
either one
That
would
makes
be fine.
sense. All right. Now, we've already mentioned this particular concept, but the cool thing about it is since you already know it, we can kind of go through it quickly, but it is a theorem, right? This is called the triangle sum theorem, and it basically says the sum of the measures of your interior angles in a triangle is 180 degrees. Now, a lot of you are saying like, well, the angles equal 180. Well, not each of them together. So if you say the sum or say together or you have to add them up, make sure you use that kind of vocabulary. So that means the measure of angle A plus the measure of angle B plus the measure of angle C, that all equals 180 degrees, which again is something you've learned in middle school. Okay?
So if you just say, if we're trying, especially once we start getting to proof and other things, if you just say, because it's a triangle, that's not going to be a
'cause
reason.
The definition doesn't say that.
Exactly.
So, the
So it's got to be
sum.
triangle sum theorem.
And you guys, when you see the word triangle, you can use the triangle symbol. So you could say triangle sum theorem. You can abbreviate things like that.
Absolutely.
Now, we're going to lead into a new word.
A corollary. All right. A corollary is just basically, it's a more specific case. It's
Yes.
a very specific case. And they're not things that we use frequently because they are those specific cases. So it's a statement that can be proven using a theorem, but it's just that more specific type of figure usually, or a more specific thing with that theorem would apply to. So when we say the corollary to the triangle sum theorem, this is talking about a very specific case within the triangle sum theorem.
Yeah. And sometimes what I think the corollary is kind of like something additional to what you already have. Okay, so if
Absolutely.
you already know, what the triangle sum theorem is, all right, so the interior angles add up to 180. So a corollary to that would be something kind of extra to that. So something more specific, maybe a special case in a sense.
Yes. And this special case is when we're talking about a right triangle. So the corollary to the triangle sum theorem says that the acute angles of a right triangle, so it has to be a right triangle, we have to know that first, that those two acute angles, so the other two angles that I have here, angle A and angle B, will be complementary. Now let's think about that for a minute.
Well, that would make sense. If I use the triangle sum theorem, I know all three of those angles add up to 180.
Oh, they're not numbered here. Let's try that again. Measure
Angle A and angle B and angle C all add up to 180 degrees. We know that by the theorem.
Right.
But if I already know angle C is 90 degrees, well then the two that are remaining have to add up to 90 then as well. So that's why they have to be complementary. So it's kind of, again, it's just a kind of an additional extension off of the theorem. What if you forget the corollary? It's not a big deal.
Right.
You can always then use the triangle sum theorem, and I see a lot of people doing that.
Yeah, me
But
too.
it's good to know that those acute angles add up to 90, because what if I told you this is like 40 degrees? Could you tell me what angle B is
Sure.
right away?
I wouldn't even have to do any work. I know
Uh-huh.
it's going to be 50.
Yeah.
And guys, I'll tell you that it's just a shortcut.
Mm-hmm.
It's a shorter shortcut even than just knowing the triangle sum theorem.
It's a shorter shortcut. I
How
love
about that?
All right, one more theorem, and then we'll be done with all the vocab and new rules today. All right, now this is a theorem that I would say out of all the theorems today is definitely a brand new one. This is one we want to make sure we understand and listen carefully, because it can be kind of tricky, and you'll see this every once in a while throughout the rest of the school year. Not a lot, but every once in a while. The exterior angle theorem, by name, I know it obviously is dealing with exterior angles. So I look even at that picture and I see that they have an angle labeled here, angle 1. That's the exterior angle. All right. And remember, exterior angle is adjacent to the interior angle. And the interior angle in this case would be angle BCA. I can't name it angle C because there's more than one angle at that vertex.
And we know that those two, the exterior angle and the interior angle together form that linear pair. That's why they show you that extension of that straight line.
Perfect. All right, so what does this theorem say? It says the measure of the exterior angle in a triangle is equal to the sum. What does sum mean?
I'm adding
the measures of the two non-adjacent interior angles. So let's kind of write down what they're saying. So they're saying the measure of the exterior angle, which is angle 1, is equal to the sum. So we're going to be adding, got to add two things.
So the measure of angle B and the measure of angle A.
And why did you choose those two angles?
Because they said the non-adjacent. So I know they can't be talking about the one that's right next to it.
Yeah.
That angle BCA.
So the two angles here, you're going to be adding those together and setting that equal to angle 1. So this would be the exterior angle theorem.
Okay. And let's talk about why that is, because that's really a good one to kind of dive into. If you guys notice that we know that the triangle sum theorem, okay, and I'm just going to call, let's just say the measure of angle A plus the measure of angle B plus the measure of angle BCA should equal 180.
Yep.
We know that.
This because the triangle sum theorem.
And I also know the linear pair that exists there. So the measure of angle 1 plus the measure of angle BCA should equal 180 degrees. Well, if they equal 180 degrees, then I know transitive, they equal each other.
Yeah, so we can just say this whole thing is equal to that, right?
So then if I took the measure of angle BCA away from both sides using a little
Yeah.
ESPO, that's where this is all coming from. So I just want you guys to realize that it can be proven. This is a theorem. That would be kind of a proof of that theorem.
Man, I'm running out of room.
It's getting a little...
So you get rid of this and that, and this is basically what you end up with.
Right, that's what the theorem says. So guys, I just want you to realize where that's coming from. Since these are theorems, they can be proven.